Hi everyone, Mr. Ince here. We're going to go ahead and go through our first section of notes in our Unit 7 notes packet, and it deals with trigonometric ratios. But first, I want to make sure that I tell you a little story from the past that I think might help reinforce these ideas. Hello! Ha! Remember that? That was a funny day. Anyhow, moving on. So here's a little bit of a story that I want to tell you. So here's story time. There was this Boy Scout leader. Okay, his name was Sokotoa. It's a really weird name, I know. But the leader's name was Sokotoa, and he was in charge of kind of creating all the different tents when these groups would go out on family retreats. So the leader, Sokotoa, you might hear me continue to say his name quite a bit since it was a little bit strange. But he noticed a few things. Being in charge of all of these different tents, he wanted to make different sizes because you have groups that are small, groups that are large, you have individuals, you have families with quite a few kids, and so there needed to be different sizes. However, they wanted to make sure that they all still kind of looked the same. And so what he did was he made sure that he had the same angles, kind of in the bottom left of those tents. You can see those with these stars. And when it came to figuring out the measurements that he needed, Sokotoa, once again, that's the name, Sokotoa, he kind of figured out a few things. He noticed, well, man, every time I'm looking from this angle, there seemed to be the same relationship, no matter if it's the medium, the small, or the large tent, but there's the same relationship between the opposite side as well as the hypotenuse side. Okay? When those measurements reduced, it always ended up being the same thing. Once again, that was the opposite side, and he would divide that by the measurement of the hypotenuse side. And then once again, it made the same thing. So man, Sokotoa, that guy was really on to something. He also noticed that that same measurement would exist when he would do the adjacent side divided by the hypotenuse side. The adjacent over the hypotenuse. He would end up getting the same answer when it was the medium, the small, and the large tents, as long as that angle was the same thing. And the third thing that he recognized was that the same thing would happen with the opposite side and the adjacent side. That if he took this measurement divided by that measurement, it would be the same thing for medium, small, and large, as long as those angles were the same for those tents. And so he really utilized that. And he kind of became a big deal within the trigonometry world because of those discoveries. Again, that person's name was Sokotoa. Makes me think of a little joke of mine. Knock, knock. Who's there? Sokotoa is there. So please try to remember that name. Just kidding, that's not really a good joke, but maybe it'll help remember that name. So now on to our notes. I mentioned that this person's name was Sokotoa, and this is how he spelled it. It was SOH-CAH-TOA. And I'm going to ask that you guys write down that name. It's so important. I want to make sure you know how to spell it, you know what it means, and you know how to use it. Okay, on to our lesson. So today we're going to be talking about the three different major trig ratios, and they're pronounced the following way. One of the ratios is referred to as sine, and that's pronounced just like what a stop sign would be. It's not sin. That's bad. Okay, it's sine. This next one is referred to as cosine, pronounced co-sine. And the third one, down below here, is referred to as tangent, as in a gent who has been in the sun for quite some time. Okay, so a tangent. Tangent. Now, let's talk about what on earth are those ratios. These are the big three when it comes to trig, so you're going to want to get to know these pretty well. So the sine ratio is going to be the ratio of the opposite side over the hypotenuse. Once again, we're going to focus in on kind of those key sides that we discussed yesterday. So the opposite side over the hypotenuse. I want you to write this a different way with me. So sine, S-I-N-E, is equal to the opposite side divided by the hypotenuse. Now what I want you to do is, in addition to this original triangle, let's actually draw another one of them with the same labels. So it's going to be a right angle. We're going to put capital letters A, B, and C around the triangle, and then lowercase letters A, B, and C in their respective positions. So we essentially have two identical twins here. The reason that I want us to do that is I want us to first examine this new triangle from the viewpoint of A, angle A, and on the second triangle, we're going to look at it from the viewpoint of B. Now, from A, this side over here would be my opposite. I'm going to label it as OPP. From angle A, this side would be my hypotenuse. And from angle A, this side would be the adjacent side. So that would mean that the sine, and I'm now going to abbreviate that with a three-letter word, SIN. That's the abbreviation for it. The sine of A is equal to, once again, the opposite measurement over the hypotenuse measurement. So from angle A, the opposite measurement would be this side, currently referred to with a lowercase letter a. And the hypotenuse side from angle A is currently referred to with the lowercase letter c. So this would be read as the sine of A equals A over c. Now if we move over to the second triangle and have our viewpoint be from angle B, that means that this side over here is the opposite. And that side A is actually the adjacent. And you'll notice that C is still the hypotenuse. That doesn't change. But the adjacent side and the opposite side do change depending on which angle you're looking from. So what that means is that if we were to look for the sine of angle B, the sine is the opposite over the adjacent. So in this case, it'll be B over A. So you'll notice how the sine value ended up changing depending on which angle we're looking from. Okay, so once again, the sine is the opposite over the hypotenuse. That's the so in SOHCAHTOA. Now let's drop down to cosine. Cosine is also a ratio, and it's the ratio of the adjacent side over the hypotenuse. Again, this would read as the cosine is equal to the adjacent side over the hypotenuse. So let's go ahead and do the same thing. I'd like us to draw the same triangle with the same values for the angles and the sides. Just a quick repeat. We'll examine the triangle on the left from the viewpoint of angle A, and we'll look at the triangle on the right from the viewpoint of angle B. So cosine, which is abbreviated as COS, the cosine is equal to the adjacent over the hypotenuse. So when it comes to the triangle on the left, if we are looking from angle A, remember this would be our opposite, this would be our adjacent, and this would be our hypotenuse. From angle B, this is our opposite, this is our adjacent. Those switch from having a different viewpoint, and this is still the hypotenuse. So now returning to the triangle on the left, if I'm looking for the cosine from angle A, I would tell myself, okay, the cosine is the adjacent measurement divided by the hypotenuse measurement. So the adjacent measurement is B, the hypotenuse measurement is C. So that means that the cosine from angle A equals B over C. Similar story, but from a different viewpoint. If I want to try to get the cosine of angle B, remember cosine is adjacent over hypotenuse, so that would be A over C. Returning to our name of our leader, SOHCAHTOA, just to repeat, to recap, the sine function is the opposite over the hypotenuse. The cosine function is the adjacent over the hypotenuse. You might see where I'm starting to go here with my good man SOHCAHTOA. Third and final one. Let's drop down to tangent. Tangent is the ratio of two sides, and it's the ratio of the opposite over the adjacent. So let's go ahead and get that note down. This would read as the tangent is equal to the opposite over the adjacent measurements. I'm going to quickly redraw that triangle so that we can look at it from two different points of view. I'm going to give it the same labels. And here we go. On the left, I'm going to be examining it from angle A, and from A, same thing. This is still the opposite. This is still the adjacent, and C is still the hypotenuse. On the triangle that was originally printed, we're going to look from angle B, and from angle B, this side would be our opposite, this would be our adjacent, and C is still the hypotenuse. On the left here, I'd like us to try to get the tangent from angle A, which would read as tan A equals, and now you look for the opposite measurement divided by the adjacent measurement. So from angle A, the opposite is lowercase a, and the adjacent is lowercase b. So that means tangent of A equals A over B. Moving over to our second triangle, looking from a viewpoint of B, the tangent from angle B would be opposite of B over adjacent of A. So the tangent from angle B equals B over A. You might start to see some small connections here. Like for instance, if we compare these, from the other angles, the tangent values just ended up being the reciprocal. Yeah? But we'll get into more of those little tips and tricks later on. So I'm going to return to my good man SOHCAHTOA. I'm going to try to keep saying that name quite a few times. SOHCAHTOA. And hopefully by now you've figured out the purpose of this name. This is just a friendly trick to help us remember what those three different ratios are. There's the sine ratio, which is opposite over hypotenuse. There's the cosine ratio, which is adjacent over hypotenuse. And finally, there's the tangent ratio, which is opposite over adjacent. So while you're working to get that kind of memorized and understood, I would always write that on my papers or maybe a quiz or test that I know some trig is going to be on, and it just helps me right away. SOHCAHTOA. So let's go ahead and flip and try a couple examples. All right, finding some trig ratios. All of those examples that we just did just had letters for the measurements, but hopefully you easily understand that a lot of things are going to have physical measurements and lengths, so numerical values. For instance, this triangle is a right triangle with sides of 8, 17, and 15. The directions for example 1 are asking us to find the sine, cosine, and tangent of both of the acute angles of this triangle, and then round to the nearest hundredth if necessary. I'm going to say that we actually end up just leaving these in a fraction as a ratio. All right, so it wants us to do both angles. So I'm going to do my viewpoint from angle P. I'm going to do those in green. And then we'll re-examine it. What do we think that is? A Q? Could be an O, but I'm going to go with a Q. So I'm going to do my angle Q values in blue. So first up, I'm going to get myself prepared. I'm going to lay it out as I'm going to look for the sine from angle P. I'm going to look for the cosine from angle P. And I'm also going to be looking for the tangent from angle P. All right, SOHCAHTOA. I'm going to go ahead and write that good name up here. SOHCAHTOA. And this is going to help me remember what those three different ratios are. So from angle P, the sine is going to be the opposite measurement over the hypotenuse measurement. So the opposite from here would be 15. The hypotenuse would be the 17. So that means the ratio would be 15 over 17. Cosine. Cosine would be the adjacent measurement over the hypotenuse measurement. So that would be 8 over 17. And finally, the tangent is going to be TOA, so that's opposite over adjacent. Opposite of 15 over adjacent of 8. 15 over 8. Next up, let's examine things from angle Q. I'm going to get myself prepared. I'm going to look for the sine of Q, the cosine of Q, and the tangent of Q. And I'm going to follow this same convention right here. So from angle Q, this is where I'm looking from. I know that the opposite is 8, the adjacent is 15, and the hypotenuse is still the 17. So the sine is so OH, so opposite of 8 over hypotenuse of 17. So sine of Q is 8 over 17. Cosine is AH, so the adjacent of 15 over the hypotenuse of 17. So the cosine of Q equals 15 over 17. The tangent, or TOA, is the opposite over the adjacent. So from here, the opposite is 8, the adjacent is 15. 8 over 15. Now maybe you're noticing something. There's a little bit of a pattern here. You might notice that the sine of one angle is actually equal to the cosine of the other acute angle. And then same thing here. The cosine of one angle is equal to the sine of the other acute angle. And then when it comes to the two tangent values, they just end up being reciprocal ratios. We're starting to get ahead of ourselves, but hey, we're kind of good like that. Let's go ahead and just kind of scratch these out for the moment in the interest of time. And you know what? We're actually going to end up calling it a day right here. Okay? So I really hope that this helps to start to explain these three different major ratios for trigonometry. And this will be all that you need for this evening's homework and for the weekend. So I'm going to ask that with any remaining time, you go ahead and start your book assignment, which I believe is on page 529. Okay. So other than that, I hope you guys have a fantastic weekend. Hey-o! And there's Mr. Ince signing off. Have a good one, guys. We'll catch you on